Hi everyone, my name is Hassan and in this video we are going to talk about throttling pattern. Throttling pattern comes under two categories of cloud design patterns, reliability and performance efficiency. And the main target of the throttling pattern is to control the consumption or the rate at which users are sending requests to our service. So if one of the users decided to send too many requests to our service, throttling pattern is going to stop them from doing this. And by doing so, we are going to improve the reliability of our system. Because if one particular user decided to send too many requests to our service, then our service will be too busy serving traffic coming from this particular user. And in a way or another, it's going to affect our service ability to serve traffic coming from other users. And throttling pattern help us to achieve this target. Also, it's good to know other related patterns to throttling pattern, like priority queue pattern and queue-based load leveling pattern. And I'm going to put links for these videos if you are interested to review them. Now, let's dive into the example to help us understand throttling pattern better. Let's assume that we have a group of users that are interacting with our service. And our service could be hosted in Azure App Service or Azure API Management. And so far, our service is able to handle the requests coming from the clients perfectly without any problems. Then over time, our service become more and more popular and more clients now interacting with our service and sending more requests to our service. And somehow, our service is still able to handle this extra number of requests as a result of the large number of users that are interacting with our service. And here comes to the interesting point. What if a particular group of users decided to send more requests to our service? In a way or another, our service will allocate most of its resources to serve traffic coming from this particular user. And definitely, it's going to affect our serviceability from serving traffic coming from other users. And because we haven't specified any throttling limit on our service yet, then our service will be executing requests or rejecting requests randomly. Maybe this particular group of users are sending 1,000 requests per second, for example, and they are going to allocate most of the resources of our service. And most of these requests will be accepted. But for this particular user, if they are trying to send 5 requests per second, for example, those 5 requests might get rejected because our service is extremely busy serving traffic from this particular user. And then these other users are going to question themselves about our service reliability and whether or not they should continue using our service or maybe switch to something else. Because somehow we weren't been able to meet the SLA we have put in our contract. And this is exactly why throttling pattern is going to improve the reliability of your system, because you are specifying a quote or certain number of calls that each user is allowed to call for your system. And if they exceeded that limit, throttling pattern is going to block them from exceeding that limit. And I hear some of you already saying that, okay, maybe you are getting too many requests, then maybe let's go and auto-scale our service to the higher tier. And it's a really good point, but before we go ahead with auto-scaling, we need to ask ourselves a very important question. Does our service really need to be scaled to a higher tier, or it's a workaround because we haven't specified the proper throttling limits for our service yet? Sometimes this extra number of requests might be an attack, trying to penetrate through our service by doing a denial of service attack, flooding our service with too many requests, aiming to disable our service or make it unavailable to serve requests coming from other clients. And if this is the case, and we go ahead and scale our service to a higher tier, then guess what? The attacker is going to increase the number of requests they are going to send to our service, until we reach to the highest tier that we cannot scale anywhere further. Then the attacker is going to increase their number of requests, and sooner or later they will be able to penetrate through our service and make it unavailable to serve other user requests. So if it's a denial of service attack, auto-scaling will give you more time until your service becomes unavailable, but it will not solve the problem. Now, we have understood the problem. Now let's see how can we use the throttling pattern and what are the different strategies we can use to apply the throttling pattern in our solution. And the first strategy we have in here is we start to reject extra requests that we are receiving from a particular client. And we can do this out of the box in API management. You can specify limit call rate by key or by quote, and you specify this as easy as that. You specify number of calls or bandwidth over a period of time for a certain counter key, whether IP address or subscription key. And I'm going to put a link that covers the throttling limit and access restriction policies for the API management if you are interested to review this in more details. Then the second strategy we can do is to disable or degrade the functionality. So we disable or degrade the non-essential services to allow the essential services to take place and to be executed. And the best example I would like to give in here is YouTube or any other video streaming application. When it experiences an extreme workload, it will switch to view the videos in a lower resolution. This is to save the platform to perform other essential services or other essential functions, rather than just stopping altogether. So this could be one of the throttling strategies you could do in your solution as well. And the third strategy we have in here is you can use a queue-based load leveling pattern. So what's happening behind the scene when the users are sending too many requests to our service is that our service needs to send these requests to a data store. And any data store has a limited capacity. At a certain point, the data store will not be able to execute all of the incoming requests at the same time. And at some point, the SQL will start to send failures to our service, and then we are going to send it back to the user. And if we are going to use a queue-based load leveling pattern, which is as simple as buffering the requests in a message queue. In this case, it's going to be an Azure Service Bus. And then we have an Azure Functions app on the other side that's going to be triggered for every new message being placed in the queue. And then the Azure Functions app is going to go ahead and execute these requests against the SQL database. So queue-based load leveling pattern could be used as one of your throttling strategies. And I'm going to put a link for the queue-based load leveling pattern if you are interested to view it in more details. Also, other pattern you can use is to use a priority queue pattern. Usually if you are using a message queue, messages are going to be delivered in a FIFO way, first in, first out. However, in some cases you might have a really high priority message that you want it to be executed straight away. And the good thing about this is that Azure Service Bus supports priority queue. That, for example, when you get a high priority message, you can specify it's a high priority, so Azure Service Bus is going to place it at the top of the queue to be consumed before other messages that are already in the queue. So priority queue pattern could be implemented as well. And I'm going to put a link for priority queue pattern if you are interested to review it. And the last strategy you can do is deferring operations that are performed on a lower priority application. So as simple as we are going to choose what are the low priority services or features that our solution provides, and then we are going to stop them for a certain period of time. And let's have a look at this graph to help us understand it better. Let's assume that our service has 3 features, A, B, and C. And this is the time. And at T1, we started to hit the throttling limit. And what we are going to do in this case is we stop the execution of feature B because it's a non-essential feature. This is to allow our system or our services to continue the execution of other essential services, in this case service A and service C. And when our resource utilization gets back to normal again, we will start the execution of feature B again. This is what we mean by deferring the execution of a certain or non-essential operation for a period of time. Also, throttling can be used for auto-scaling very well. All of us know that when we auto-scale a certain services, it doesn't scale immediately. It will take at least a few minutes for the new services to be effective. And throttling in here will help you to ensure that your system is still reliable and still able to serve user requests until the new auto-scaling services are effective. So we have time here and we have resource utilization, and at T1 we have hit the throttling limit and we have started to do the auto-scaling for our services. But until the auto-scaling become effective, we are going to slow down the execution on these resources to try to save our system from failure and make our system available to external users until the auto-scaling resources become available. So throttling in here will help you to ensure that your system doesn't fail while you are waiting for the auto-scaling resources to be effective. Now let's talk about some considerations you need to be aware of when you use this pattern. First of all, you need to be aware of throttling is an architectural decision. We already know that Azure makes it really easy for us to specify throttling limits for some services like API management or functions app. However, if you are going to follow up the strategy that's going to degrade certain services or disable certain features of your system as your throttling strategy, and you need to incorporate this early on in your system architecture and in your design phase. Also, when you apply throttling, you need to apply it as soon as possible. If you find that a particular user hits a throttling limit, you don't need to wait few minutes before taking the throttling action, because in these few minutes, the user can make really big harm to your system. So when your throttling limit has been reached, you need to apply your throttling strategy straight away. Also, it's good to let the user know that they have exceeded the throttling limit that we have specified in our system. Throttling doesn't always mean that we are under denial of service attack. It might be a genuine traffic coming from a valid user, but they are just sending too many requests to our service. And if we just let them know that they are sending too many requests to our service, probably we would be able to solve the problem before it's even started. And there is an HTTP response code, which is 429, we can use, which is going to indicate that the user is sending too many requests to our service. Last point is that we can use throttling with auto-scaling, as we have talked about already in the last slide. Now let's see when you should use this pattern. When you have an SLA for your system that you need to maintain. And in order to maintain this SLA, you need to make sure that not a particular user will be able to consume all of the computing power or resources of your service by sending too many requests to your service, which is going to affect your service to meet the SLA that you are compliant with other users. And also it will help you to handle the bursts in activities. If your system is expecting to get a really high requests at any point of time, throttling pattern will help you to handle these requests. Also, it will help you in cost optimization. Remember, earlier on in this video, I have talked about scaling up our resources to handle this extra workload that we are experiencing, which is going to have a more cost associated with it. So if you are implementing the proper throttling strategy, it's going to avoid you from this extra cost that you have to pay if you decided to scale your services up to the next tier. That's all you need to know about the throttling pattern. Now we are coming to the end of this video. I hope now it's clear for you what the throttling pattern is about, why it's important, how we are using it, what are the different throttling strategies you can use, what are the considerations you need to be aware of, and what are the best use cases to implement throttling pattern. I hope you enjoyed this video. If you have any questions, please put it in the comments below. And thanks for watching.